This flash drive contains every file that has ever and will ever be made. It has every document, every image, every video, password, game, and program that you could possibly write to a digital file system. Indexing the entire drive is literally impossible, and if you try to copy just the data that can be indexed, you would need more bytes than there are atoms in the universe, by several thousand orders of magnitude. And yet, it's just a USB stick. Or is it? In this video, we'll obviously talk about how this is possible, and maybe discuss some more practical use cases, but before we do that, let me give you a quick demonstration. When you first plug it in, you're met with a massive list of thousands of seemingly random folders, each containing even more folders. This makes sense. After all, a flash drive that has every file will naturally be filled with meaningless garbage. But this also means that if you know where to look, you can find specific files. I wrote a program that can tell me where to find any file that I give it. For example, let's give it a part of the script for this video. The resulting path is very long and seemingly random, but when I copy it into the file explorer and find the exact file it's pointing to, we see that it is in fact the very script that I'm reading from right now. Which brings us back to the question, how is this possible? Let's start with the obvious. This is not a normal flash drive. Actually, it isn't even a flash drive. It's a small computer that simulates a USB device. Every file and folder that it reports is generated on the fly. You've probably already figured that out by now. But what makes it special is the algorithm for generating those files. It's one thing to simply generate random data, but ensuring that every file can be found at a consistent location with no duplicates is a bit more involved. We'll start with a simple objective. Create a folder that has every number from 0 to 100, where each number is a file. Seems simple enough, right? That's just 100 files. A computer can do that without breaking a sweat. But now, let's increase that to 1,000. Still easy? What about 10,000? 1,000,000? 10 million? Okay, I think you get the point. We can't keep going like this forever, and it's not because of some integer limit, no, it's much dumber than that. Most file browsers just can't display that many icons. From my testing, the most you can reasonably do is 5,000 before things start to slow down. So, okay, let's come back to the drawing board. Is there a way that we can represent large numbers without a million items in one folder? Well, one way to do it would be to treat the number not as one value, but as a series of digits. There are only 10 decimal digits, but combining them can create any number. In other words, we can simply have one folder for each of the 10 digits and a file representing the current value. The first file would be empty, but if you go into the 1 folder, the file there would contain the number 1. If you then go into the 0 folder, the file there would contain the number 10. If you go into the 5 folder, then the file would now say 105. You could keep this going on and on without slowing down the computer. Each new digit wouldn't be a whole order of magnitude more expensive. It would only require one extra folder. Now, obviously, the real implementation wouldn't encode strings of digits, but it's close enough. Files on a computer are basically just a bunch of numbers, just in a different shape. But you still can't keep this going forever. Most file browsers have a limit for the total length of a file path, which means that after enough folders, we do eventually reach a wall. While we could just cheat by using a more lenient file browser, I feel like that kind of defeats the point. It doesn't quite feel like magic if it needs a special program to work. So this seems like the part where theory gets put into practice, and we start testing things with some actual programs. To keep things simple, I'm not going to get into the fine details of all the code. If you want, you can read that for yourself on GitHub, links in the description. But if you happen to be one of the people who want to understand the code but can't because you're not a programmer, then let me offer you a genuine suggestion. Go and try out boot.dev. Yes, that's the sponsor of this video, but it's also a free resource for learning how to code and building your own applications and projects. If you clicked on this video, you and I aren't so different. We both like messing with computers, and for me, programming is an essential aspect of that. Boot.dev is your way in. What I like most about it is that they're not trying to sell some get-rich-quick scheme. Unlike other platforms I've tried, boot.dev doesn't try to drip-feed you just enough knowledge to keep you hooked, but not enough for you to actually learn. This genuinely feels like a community. Many of the courses are made by fellow YouTube creators. They have a community Discord server where you can seek advice and inspiration from other coders. And of course, they've got plenty of material on site to actually learn from. Like, okay, bit of a spoiler, but this project did involve some bare metal memory management in C. And would you look at that? They have a course on exactly this topic. I'm not joking when I say that this is a genuinely useful resource for stepping into the world of software engineering. And sure, if you don't like C, they've got web development, they've got databases, they've got Python, whatever you need to either start a hobby or even strive for a job in the tech industry. As I said, the whole thing is free to try, no commitment. But if you do decide to take things more seriously, their premium plan is what makes it worth the time. That's where you unlock the interactive lessons and gamification elements that make it so much easier to keep yourself motivated and learning. To get started, you can scan this QR code or use the link in the description and enter code PortalRunner to get 25% off your first payment. While I was waiting for my souped-up flash drive to arrive from AliExpress, I could use Fuse to emulate basically the same thing, just on my computer instead of a USB stick. Fuse stands for File System on User Space, and it's essentially a Linux tool that lets you program a fake folder. When an application asks the operating system for the contents of that folder, the request gets redirected to my custom code, where I can then generate our fake files and folders. When another program wants to see inside of one of those files, my code can once again intercept that call and generate the file's contents based on the file's address. This is how we can test out the logistics of our project before messing with actual hardware. So let's come back to that issue from earlier. Most file browsers eventually restrict the length of a file path. Even though the file system itself might be infinite, the computer can't necessarily index into infinity. So how can we at least make the best of what we can index? Well, first of all, using just one digit per folder is incredibly wasteful. 50% of our path is taken up by these slash characters that don't encode any information. But then again, increasing the amount of combinations within a folder quickly gets expensive. We need to strike a balance between the amount of useless slashes and the amount of files within a folder. One parameter we can tweak is the numeric base. So far we've been working in base 10, which has 10 digits, but a file name could consist of more than just numbers. It can have uppercase and lowercase letters as well as some symbols. From this, we can create an alphabet where each valid symbol corresponds to a sequential number. This way, with just one character, we already have way more combinations than before, and with 2 or 3 characters, the amount of combinations explodes. But, of course, increasing the base also increases the amount of files in a folder, which adds yet another factor to our already delicate balance. To summarize, we need to maximize the total amount of combinations while keeping the amount of files in each folder the same, by changing the amount of digits in a single folder name and the size of our alphabet. Those first two are constraints, and the other two are variables. The correct way to solve this would be to use nonlinear programming, which doesn't actually involve any programming. It's basically a bunch of complicated math that finds optimal values given a mathy description of our constraints. But it's a lot easier to simply write an actual program that brute forces the answer by simulating every possible scenario. And yep, there you go. Assuming a maximum of 5,000 files per folder, the optimal parameters are an alphabet of 70 digits and a maximum of 2 characters per folder. I'll admit that's not a particularly satisfying result, but I'll take it. Of course, all of this is really just a warm-up. These examples rely on the Fuse driver that sits right on top of the operating system and can talk to it directly. Real external file systems, like those in a flash drive, aren't gonna be this flexible. When you connect a flash drive to your PC, the computer sees the raw bytes on the flash chip. Instead of requesting individual files or folders, it queries for ranges of bytes at specific memory addresses. The only way to make the computer believe that you've got thousands of unique files is by reporting a plausible memory layout for each of those files. The thing is, these addresses are finite, and they can't overlap. So if our goal is to make an infinite file structure, a regular file system makes that physically impossible. But hold on, I'm not actually using a flash drive. What I'm using is a microcontroller, which is basically a small computer. It's only pretending to be a flash drive by simulating USB signals. While the normal USB storage protocol expects a physical file system, there is another protocol that looks and feels like a flash drive, but doesn't care about the physical media underneath. Enter the Media Transfer Protocol. If you've ever connected your phone to a computer through a USB cable to transfer photos or videos, you've probably already used MTP, and you might have also noticed that the files you see on the computer don't exactly match the files on your phone. That's because the phone isn't exposing the raw bytes on its internal storage. When the phone is first connected, the computer asks it to list the files and folders in the root directory. The phone can then choose how to respond. It doesn't have to list its actual root directory, it can list just the photo album, for example. The computer can then ask for the contents of that folder, and the phone can once again decide what files it wants to return. It can even generate new files on the fly. If we make our USB stick roleplay as an MTP device, we can take advantage of this. When the computer asks our microcontroller to list its contents, we can just generate that list of 5,000 folders. If it asks what's inside of one of those folders, we can just give it that same list. If it asks again for a different folder, we again give it the same list, on and on until infinity. In the meanwhile, our program can keep track of which folders the computer has requested, and when it's finally time to return a file, it can use that path to build the file's contents, as previously discussed. In case this part still feels a bit unclear, it might help to imagine the file path as a cipher of sorts. To get the contents of the file, we just do some math to decrypt that cipher. This is, of course, an oversimplification, but it's good enough for intuition. The real logic behind it is a bit more involved. In reality, we're not storing the file path as a string of text. That would be incredibly wasteful. So instead, we give each folder a number from 1 to however many folders there are. With our current settings, that would be 4,900 possible folder choices on each level. So to list the folders we've been in, we just need a list of these numbers. Now, here comes the magic. You can imagine that this list is actually one big base 4,900 number, where each digit represents a folder. We don't actually have the symbols to represent digits that large, but the important thing is that we're now treating this as one whole number, rather than a list. Then, to turn that into a file, we just need to convert this number from base 4,900 to base 256, because each byte of a file has 256 possible values. But if this is all we did, we'd have a bit of a problem. Numbers can't have leading zeros. There's no such number as 010, for example. That's just 10 with an extra 0 at the start. In our case, this would mean that we can't generate files that start with null bytes, and that's obviously not acceptable for a flash drive that's supposed to contain literally every file. To fix this, before outputting the file, we subtract 1 from every position in the number, starting with the least significant end. This would mean that to represent 010 in decimal, you would use the value 121, which is a valid number. It's only when you do this subtraction that it becomes a byte sequence. If you wanted to represent the number 9 in decimal, that's still possible, of course. The input would be 10. You subtract from the 0, which carries to the 1 and gets you 9. Now, technically, there are still a few limitations here. For one, the MTP spec demands that each file and folder you encounter is identified by a unique 32-bit number. That's a bit of a problem because 32 bits is not infinity. Theoretically, this means that we can run out of folders, but in practice, if you play your cards right, the maximum depth you can reach is close to 1,000,000, which is way past the limit on file paths. And on top of that, it seems like this is only really enforced on Windows. On Linux, at least from my testing, you can just reuse the ID numbers, and it really doesn't seem to care. The other major limitation is that the maximum file size is limited by how much memory the microcontroller has to hold that giant number. This would be a serious problem, but these USB sticks have an SD card slot, so you can easily expand the maximum file size. And with that out of the way, I think it's fair to say that we have achieved a practically infinite flash drive. The only limiting factor is the computer that it's connected to. The USB stick itself is more than capable of serving literally any file. Of course, this is just a silly little gimmick. It's really not practical or stable, but perhaps there is a way to use these concepts to build something at least mildly useful. Here are just a few of my ideas. You could make a flash drive that only reveals its contents if you go back and forth through some folders in a specific order, kind of like a secret code. Or you could make a drive that looks empty at first glance, but has a secret hidden folder that can only be opened by entering its name. Or because this thing has a screen on it, you could technically play Doom by using folders as the inputs. For a while, I really debated whether to make the video about this instead, but memes aside, there really wouldn't be all that much to talk about. If you want to get your hands on one of these USB sticks yourself, you can find them on AliExpress for like $10. And of course, all the code for this project is on GitHub, with some basic instructions on how to set it up. Though please keep in mind that this is really not a beginner-friendly thing. I am not going to individually help everyone who runs into problems, and I'm not planning on maintaining this code. If you have any questions, use a search engine. So, I figure you're probably gonna go back to the homepage now and look for a new video to watch, or maybe try to pick one from the sidebar, but let me save you some trouble. Clearly, you liked what you saw. I mean, you watched the whole video to the end and you're still watching, so why not check out my other videos? If you like this one, chances are you'll like those too. Or if you're looking to get off YouTube for a bit, maybe consider checking out boot.dev. Again, it's free to try, and programming is a genuinely useful skill to have. Either way, I'll see you around. Thanks for watching.